Welcome back to this next section of functions. Here we will be covering 4.7.1, which is the existence of a composite function, and 4.7.2, which is the domain of a composite function. In the earlier section, we talked about what is a composite function, but let me tell you, not all composite functions exist. Why do I say that? Let us consider GF first. Okay, GF. GF is this, right? F first, then G, right? Why? Because if it's X, it is Fx, then it's GFX. Just think of it like that. So therefore, this is GF. If you consider say the value 0, okay? 0 because why? Because F can be 0. I mean, the domain of F is X greater or equals to -2. So 0 is the domain. You sub 0 in, you get e to the power of 0, which is 1. -1, you get 0. No problem. You put 0 into G, no problem. Here, you get square root 0, you get an image. No problem. Okay. Let's have another value and see what happens. What if I put -1 here? -1, if I put in, you use your calculator, e -1 minus 1, you will get -0.632. Okay, trust me when I say that. And -0.632, we will face a problem. Why? Because if you look at the domain of G here, actually G cannot take in negative values. So here got no image, cannot. So just because of that, GF does not exist. Just because of that, GF doesn't exist. Why? Because there is one particular element here, -1, that has no image under GF. Later on, I'll give you a comprehensive way of testing it out, but I'm just trying to explain the idea of it first. How about FG now? How about FG? Sure, let us take a look. FG is this. This is FG. If you take a look at the domain of G, actually is 0, 1, 4, 100, blah, 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 all the way. Am I very sure that FG exists? Let's see. If I undergo G, I will get 0, square root 0 equals 0, you got square root 1, square root 4, square root 100, etc., etc. All these are positive numbers again. Do all these elements here have an image under F? The answer is yes. Why? Because the F can take on values greater or equals to -2, and all of them have got images. So I'm going to say this now, as long as these values, the range of F, I repeat, the range of F, sorry, I repeat, the range of G, I beg your pardon, the range of G is a subset of the domain of F, then we are good. In this case, if you see here, the range of G is from 0 to infinity. This is the range of G. The domain of F is -2 to infinity. And this clearly is a subset of this. All these have images. So I want to conclude, for Fg to exist, the range of G must be a subset of domain of F. Why? Don't memorize. Go back to this earlier example and you will know. As long as all these values, 0, you get square root 0, you get all these values, which is the range of G, will continue to have an image. Each of them will all continue to have an image under F. How do you continue to have an image? It must be a subset of F. It need not be equal, as long as the subset is good enough. Then that's true. Please don't memorize, rewind, play again if you're not clear. I also want to talk about the domain of a composite function. It's quite obvious. This one you can memorize. Domain of fg is actually domain of g. It's too clear. If you see here, this is fg, right? You take from the same set of numbers to process in that sense. fg and g are the same set. Once you see this, you're quite clear. I want to talk about example 13, right? Determine if fg or gf exists. If so, define. Actually, this one I'm going to leave you to read on your own. I just want to focus on this one. Determine whether GF or FG exists. The correct way to do it is this, right? How do we, let us first talk about GF. Let us first talk about GF. Remember, for FG to, for FG to exist, range of G must be a proper subset of domain of F. For GF to exist, then range of F must be a subset of domain of G. You just swap the letters around lah. Don't memorize too much. You know what I mean? You just memorize one. So let's talk about GF. I think it's easier if you think about it like that. GF is F first, then G. You want to make sure all this range of F must be a subset of a domain of G. So to find range of F. If you find the range of F, I think we have earlier, I directly found, actually it's from 0 to infinity. You sketch the graph and you realize that this is a square root graph, confirm it's just 0 to infinity. This is the graph of F. You write down domain of G. Domain of G is given like that. It is from -2 to infinity. Is it clear that it's a subset? I think it will be useful if you draw a number line. This is the range of F. This is the domain of G. Is it a subset? Of course it is. Range of F is a subset of domain of G. Therefore, GF exists. Done. I think I don't want to talk about this one as the similar manner one. Okay, you will read on your own. Let's then decide whether FG exists. FG is this. Correct? And you want to decide whether the range of G is a subset of domain of F. Yes? So what are the values your Gx can take, basically your range? So in order to help us to find the range of G, you will sketch this graph. Like that. And take note it's greater or equals to -2. There is a value, -2, E -2 -1. And by the graph, you will see that this value, the range is E -2 -1 to infinity. Why? Because it's an upward sloping graph. Upward sloping graph. When x is -2, the y value is E -2 -1. And it's upward sloping. So therefore, it's from this one all the way to infinity. Go and check your notes for how to find range earlier if you are not clear. Domain of F here, 0 to infinity. Yes? Then you can draw a number line and you realize that here E -2 -1 is negative. E -2 -1 is negative. So this value, this one, is the range of G. This one is the domain of F. Is the one below a subset? There are some values here that are not included in the domain of F, which one of it was -1 earlier, which I shared. So therefore, how do you write? You say range of G is not a subset of domain of F, therefore FG does not exist. Please rewind and play again if you're not clear. That's that for this section.